Hello, and welcome to the Question 12 walkthrough of the Spring 2019 MAS 1 exam. Let's get started. You were given the following information for a whole life annuity due of $10,000 on X that is payable annually. Q of X is 0.01, Q of subscript X plus 1 is 0.012, interest rate I equals 0.06, and then A double dot subscript X plus 1 equals 10.905. Calculate the absolute change in the actuarial present value of this annuity due if P subscript X plus 1 is decreased by 0.01. In this question, first thing to know is that annuities due are paid at the beginning of the term, that is, as opposed to annuities immediate, which are paid at the end of the term. And then the second thing, which we touched on this briefly for question 11, is that when dealing with these life contingency problems, discounting annuities needs to take into account both the interest rate as well as the death rate. So in exam FM, you can think of it as you were doing physics problems where you ignored friction, and now we're trying to take that into consideration. So if you die, you're not going to be around to see those later payments. So we got to take that into account as well. So the first thing that we do is kind of just write out the long form of the formula for these annuities. So we're going to start with this subscript X plus 1 because we have that annuity's value of 10.905. And for this problem, we know we're going to be coming back to this Q subscript X. So I just feel like that's something worth pointing out or maybe underlining, because it's going to be easy to go off on a tangent of solving something with X plus 1 and then get carried away and answer the question before you realize you got to bring it back to subscript X at some point. So again, annuity due is just you get a dollar payment at the beginning of each term. So the way that looks is for this first year, I'm going to get a dollar payment immediately, and since I got it at the beginning of the term, it doesn't need any discounting. The second payment has to be discounted one term, so that's this fee, as well as it is only going to be applied to those who live to see the second payment. So P subscript X plus 1 is the conditional probability that you, from the previous term, live to the following term. And to kind of further highlight that notation, if we go to the next payment, so this is the very beginning of the third year, so 2 years in the future, you need to discount it back 2 years, so that's that v squared. And we only want to consider those who are alive at the beginning of the third year. So what we do is this conditional probability, or the probability of seeing year 2 starting at year 1, and then that multiplied by P subscript X plus 2, which is that same thing shifted a year. So given that you survived through year, that second year was the probability that you're going to live to see the third year. So you can see you just keep adding a single discount term as well as the next probability of survival. Now the reason we're writing this all out is because we also know this term here, these Q terms, which are just the 1 minus value of these P's. So Q is the death rate, the probability you die in that given year, as opposed to the probability you survive it. So what we want to do is get access to this Px plus 1 and be able to do some simplification. So first off, we're going to subtract 1 from both sides, and then what we can do is pull out this common factor, because you'll notice it shows up in every term, and we can just pull that out here. So now we can abstract away the rest of this formula, since we know that at the end of the day it's going to equal this 9.905, and just say try to solve this long quantity. and we do that by subbing in for this px plus 1, 1 minus the death rate, and that was that 1.2%. So finally we get that this mess on the right is just equal to 10.0253. What we can then do is go back to that formula and say, okay, but now what if we consider the death rate increasing by 1 percentage point, and that's the same as the survival rate decreasing 1 percentage point. So we're just going back to, let's see, this formulation here, and adding that one term back in, subtracting off that change in death rate, and then multiplied by this right-hand term which we just solved for previously to get this new number 10.8. So then moving forward, we want to, we kind of have a sense of how that impacts the annuity due of subscript x plus 1, but again we care about subscript x. So going back up to the problem here, calculate the absolute change in actuarial present value. So we care about things being in terms of year x. And so what that means is for the annuity due that we have, we need to discount those payments. And since it's x plus 1, we discount it one term. And then we also consider the probability that you survived that very first year. And so this is discounting by the probability you survived that first year as well as the discount rate. We also have this 1, and that's because that very first payment at time x doesn't require any type of discounting because it happens at the beginning of the term, and we do this on both sides. The last thing is just multiplying by 10,000 because they're $10,000 payments, and then we just do some algebra. So that discount rate assumed 6% interest rate, so it's just 1 over that, 1 plus that interest rate. And then we also have a death rate of 1% in that first year. And so we know that the survival rate is 99%. Solving all this, we get 936.8, and scrolling up, we see that's answer C. Thanks for watching. If you enjoy these videos or find them helpful, please consider subscribing. Thanks. Have a good one.